Hello, my name is Todd Anslinger. IoT and Automation Specialist in the Chevron Technology Center in Houston, Texas. Today I'm going to talk about IoT best practices in oil and gas manufacturing. So a little bit about myself, 21, 22 years with Chevron, grew up as an automation engineer. Last 6 years have been really focused on IoT solution deployment. That's where I went to school, originally from Indiana, but I'm a Texan now. I've been there longer than Indiana. Get to sit on some cool advisory boards with Rockwell or leadership teams, the MQTT Sparkplug B and ARC Digital Transformation Council leadership team. When I'm not working, I like to have fun by volunteering. I'm the AV director at my church, so goes out to you AV guys, because I know it's not always a thankful job. And I'm trying to stay in the mic too, by the way. I video the football games for my boys when they play on Tomball Christian Warriors homeschool football, and Chevron Golf Ambassador. So Chevron sponsors part of the Houston Open PGA event and the Chevron Championship, which is an LPG event. So I like to volunteer and take my kids and support those golf outings when they happen. So the journey of a barrel of oil, we're hitting the manufacturing, which is good because we're doing smart manufacturing right here, right? So normally my talks in years past have been more in 2 or 3 development and production, but this year I get to talk about manufacturing, so get to hang with Craig. So, but before I get granular into what we're doing in IoT for manufacturing, I want to level set on Chevron's definition of IoT. So, I can remember sitting in a DTC meeting here 5 years ago, and someone said, well, we've been doing IoT for 15 years with wireless HART devices. No, we don't consider IoT to be anything wireless. It's really about the network connectivity. So if it's a cellular device, it reports straight to the cloud. If it has some sort of gateway like WiHART, LoRaWAN, what have you, that reports straight to the cloud. For us, that's the definition that does not logically touch the Chevron network. And this is mainly for a cybersecurity reason. I know last year I got into details into the 6 reasons why this makes sense versus PCN. By the way, since I'm an automation person, I have to shout out here. This is for non-closed loop process control devices. So this is only for monitoring. So I want to make sure I point that out, that we're getting the information to the cloud, doing our analytics there, notifying the operators to say, hey, you might want to make a change here, but it's still dependent on the operator to make that because this is monitoring only. This isn't touching PCN, DMZ, level 4 at all. Just want to clarify that. So now that that's out of the way, I want to get really into the nuts and bolts. What are we doing, all right? So oil and gas smart manufacturing, IoT monitoring solutions, remember monitoring. And I want to talk about external floating roof tilt monitoring, manual valve position monitoring, steam trap monitoring, non-intrusive submetering, electrical monitoring, and pipe wall thickness monitoring. So you've heard, I know Chris talked about the steam trap. So if you're discrete manufacturing, 4/5 of what I talk about today, maybe you can grasp and use. You may not use the floating roof tilt. So we're going to start with roof tilt monitoring. And these questions that I have here, you're going to see them on all 5 slides that I do, all right? And I'm not going to talk anything technical. That diagram, that's the only diagram you're going to see from me. This is how I talk to the people in the field, all right? So as you're trying to get people to use your new technology, it's not about the technology, it's about what it can do, business value and safety for your guys. So get good at asking these questions. So with roof tilt monitoring, what are we trying to prevent? We're trying to prevent that roof from tilting and compromising the tank, having a spill, environmental event, right? Or puncturing a hole in the bottom type of thing. So what's the work process now? Well, now, as we're pumping in and out, the roof doesn't move fast, but if you see that ladder that goes down there, as we're pumping in and out, sometimes that thing hangs and it starts to tilt, right? So operator has to walk up on there or fly a drone up there and see what's going on while they're pumping in and out. The other thing that happens is in a rainstorm, they drive around and they look, I think this is a drain right here, they look and see if there's water coming out of those drains because it comes on the top of that roof and then flows out. Well, if there's no water coming out, maybe there's dirt up there or mud daubers built a nest and water can't get out of there. So they're driving around, looking around for water coming out of those spouts. And then after the rainstorm is done, they might walk up on top of there, see if there's water puddled up, or fly a drone, kind of like this view here, see if there's water puddled up in there, all right? So what's the process of when you have an IoT solution, what do they do? So what we did is at every 120 degrees around there, we put a measurement device. And in the control room, it'll alert them if it sees any measurement more than 6 inches off from each other, right? So it's nothing that sit there and have to watch. You know, if they want to use it for a secondary level device, okay, they can look at it. But we're not making them look at a trend. Notify them when there's a problem. All right, so so how does that affect your operator and what's the business value? Well, they don't have to drive around in the rain, take a chance of hitting something in the rain. They don't have to get wet. They don't have to climb stairs. And you don't have to maybe recover a drone if you're not a very good drone pilot. And then of course, business value. What I'm showing you here is the view into the refinery. What you don't see is, this is looking the other way. All right, this is Manhattan Beach in El Segundo, California. So I don't know what came first, the chicken or the egg, the refinery or the $3 million houses. It doesn't really matter. You know, we're both working together now, so we're doing what we can to be good stewards of the environment so these guys don't get upset with us, because we've got to work together. So next one, manual valve position monitoring. What are we trying to prevent? So we're moving product or blending product from one area, putting it into one of those floating roof tanks or pumping it out to a ship. We're trying to prevent valve mislineups, because if you destroy your stock or your product, that costs a lot of money, right? So what was the work process? Well, these are manual valves. They don't have actuators on them. So they go around, they open or close a valve, they get on the radio. This is the outside guy, the radio to the control room, say, hey, I opened valve 584. And the guy in the control room says, okay, I marked it on my spreadsheet, okay? Not spreadsheet, there's some valve system. But so that's the work process now. If they're at the wrong valve, we may not know it until we turn the pump on and say, hey, this tank level is not rising, what's going on? So what's the process with the IoT solution? And that is, it's the same thing, they're manual valves, we don't have automatic actuators, so they're still walking around turning that valve. Now what you can't see is behind his wrist is a little sensor on there. Now he says, hey, I'm at valve 584, and the guy in the control room, it should be open, the guy in the control room says, hey, I'm looking at the dashboard and I see valve 585 is green. Are you sure you're at 584? And he looks down, oh, yeah, wrong one, sorry. Closes that one, goes and opens the next one. It's a verification point, right? To make sure we're not gonna misalign something. Because, to the next point, how do you justify this? One valve misalignment pays for us to put IoT sensors on all those valves 3 times over in one refinery. So that's a slam dunk, right, for implementation. Next, I want to talk about steam trap monitoring. So Chris mentioned this in his presentation. What are we trying to prevent? We're trying to prevent steam leaving the plant by blowing through this trap. And we're trying to prevent, if that trap is bad, we build up condensate and it gets up here in this steam main and it cuts off steam to a part of one of our processes, right? Which causes shutdown and we lost production. So the work process now is on a time-based frequency, someone goes around and checks that steam trap. You know, they feel it or get close to it, see if it's warm or cold. They listen to it and see if you hear shh, and it never goes away, you got a problem. All right, so what's the process with IoT solution? We have a monitor on there that's acoustic monitoring. You can hear if it's going shh, and it'll let you know. It also monitors the temperature. If it goes cold, you know that mechanically this thing is messed up, it's not letting any condensate out, right? So how do we justify that? Well, if you're not gonna shut down your plant and do lost production is your biggest value, business value from standpoint is lost production. You know, I don't know if you don't produce grain or something from a Cargill standpoint, if we're not producing oil, that's a big loss. I used to do work at General Motors. If you don't produce a car, that's $15,000 every 30 seconds. So Similar things here. If we're not producing oil, you're losing a lot of money. Now that's more the catastrophic thinking. If we're getting rid of, if steam is blowing through, we have several traps that say it's letting steam out of the plant. Well, what's happening upstream? We've got a boiler that we're boiling water to get steam, right? What do we use to boil the water? Natural gas. So it doesn't take much of steam being lost for you to save natural gas to make up the cost of putting these steam trap monitors all over your plant, right? So again, think about these questions. These are what you're talking to your operations supervisors, your operator people, that you're speaking their language is, okay, how can I help you do your job? You know, if there's an operator that's responsible for these and they figure out that we had a shutdown because we lost steam, you're saving that guy from getting in trouble. Now, I'm not a fearmonger, but when they realize, oh, you're trying to help me do my job, you're not trying to replace my job, then it's about trust. It's that relationship you're building. So next one, non-intrusive power monitoring. What are we trying to solve? You know, we're metering stuff at the MCC level or the sub level. You may not see stuff because it's not as granular at that point. So if we can put these IoT devices on here that monitor, you know, phase A, B, and C on a pump, you might see that there's a phase imbalance from an amperage standpoint. You might see the amperage, you know, creeping up, which means maybe your seals are going bad. You might see the amperage creep going down, meaning you're cavitating your pump. So you can tell a lot of things based on that information that if you're monitoring it all the time. You know, what was the work process before? You may go to the pump fails. You may go and with a clamp on ammeter, you know, every year or something and check every pump. But again, that's what I call manual SCADA. I don't want to pay my operators to be manual SCADA, right? If we can put something low cost on there that gives the information even once a day, that's better than once a year or once every 2 years, right? So the justification is if you see amperage going up, you're like, oh, last time that happened, the pump seals are bad. So let's put that on the docket to change that out a month or two from now when we have a shutdown. Let's do some forward-looking maintenance and get that knocked out so we don't have it, again, trying to prevent that unscheduled downtime, right? Scheduled downtime should be less than unscheduled downtime from a lost production standpoint. And then lastly, pipe wall thickness monitoring. What are we trying to prevent? Trying to prevent loss of containment, right? We don't want a hole in the pipe. So if you think about on this elbow, if you've got natural gas production and it's got frac sand in it, every time you hit that elbow, you're grinding away at that metal, right? Or if it's, let's say it's a pipeline, a gas pipeline, and you have liquid sitting in the bottom of a horizontal that's corrosive, you're corroding the bottom part of your pipeline, right? So what's the work process now? Hopefully it's not run till failure. We don't want that. We don't want any environmental, you know, gas or oil, whatever, getting in the environment. So it's likely on a time-based, again, change out. You know, are we going to run a pig through there so often? Are we going to have this elbow in stock and we change it out every, I don't know, quarter, every year, you know, which is likely 4 to 5 times more frequently that we really actually need to. But, you know, we don't want to have any loss of containment, so we're going to do that. With the IoT solution, this guy wakes up and takes a measurement of that thickness of that pipe once a day. And it's going to tell us, hey, 6 months from now, we're going to be down to a thickness where we're not really comfortable with. Make sure you got that guy on order. Make sure it's ready to go in this next shutdown. And that helps them to plan their shutdowns, right? Because the business value is we want to be good stewards of our environment. So we want to make data-driven decisions, you know, maintain by exception, not do time-based maintenance, and really get our guys, our operators, focused on doing stuff that increases value rather than time-based maintenance. And all this is to remind us, you know, I love what I do. I do what I do to support my family. Just remind us all, you know, work your tail off at work, do a great job, but save some energy when you get home to do a good job with your family too.